Hi folks, so today we're going to start Unit 8, and Unit 8 is called logs, so it's logarithmic functions, but the short of logarithmic functions is logs. We're going to start with 8.1, it's understanding logs. Let's get started with the concepts. Okay, so in Unit 7, we learned about exponential functions, right? We learned about y equals to c to the power of x. The inverse of an exponential function is known as a logarithmic function, which again in short is known as log function. Or, you would just say, hey, I'm doing logs. Okay, so that's just another way of saying it. But basically remember that the inverse of an exponential function is logs. And you know what the inverse is, right? So if you want to try and cancel out the inverse, you can take the log, okay? Because they negate each other because that's what inverses do. But we'll get to that in a bit. Logs are written in the form of y equals to the log of cx. The c is a subscript, okay? It's kind of like log of cx, so this is a subscript, okay? Where c has to be positive, okay? And it cannot be equal to 1. So keep those things in mind, please. C has to be positive and it cannot be equal to 1. C is known as the base of the log function, which is commonly 10. So because it's the subscript, it's pretty easy to remember that this is a base, okay? And it's commonly 10. So if you just write log of 3, like without a subscript, it is implied that we're writing log 10 of 3, okay? So when nothing is given to you, like a base is not actually written down here, it's implied that it's base 10 because that is mostly what a log is when there's no base, okay? So a common log is known as a log with base 10. So if I just say find the common log of 5, it just means find log of 5, which is the same thing as log 5 to the base of 10, okay? Explain. So now we're going to talk about how to go from logarithmic form to exponential form and how to kind of express each other. Express logs in the exponential form, okay? So if you have log c of x equals to y, what I want you to remember that this base here becomes the base here. So you just kind of move it here and push this guy up. What that means is this c will now become your new base to the exponent and you push the y up into the power. Equals to your x, this stays the same. And that's how you express a log function in a exponential form like this. You can go from one form to the other, you just have to practice them quite a bit. Okay, so remember the base here becomes the base there and pushes this up and the x stays. If you want to go from this form back to that form, remember the base here will become the base of the log, x will stay the same, and the y will pop back down. Okay, so these are just tricks that I'm giving you to try and remember how to do the exponential form from the log form. Now, some things that I want you to remember, these are not just, these are rules, so they're not something optional. You have to know them and have to follow them. Log of any number, like log to the base of any base of 1 is always 0. So whether you do the log of 5, 1, or whether you do the log of 10, 1, like whatever your base is, if you do the log of 1, your answer is always going to be 0. If your base and the log are matching, like if you ever take the log of, for example, 5, 5 like this, where the base is 5, the answer will be 1, okay? Now, this guy right here, what I'll do is I'll erase this so I can explain that one a little bit in detail. If you have the log of cx, the way you want to think about it is this x comes out like this multiplication. So you're left with x log c of c, and from the rule number 2, I told you that this becomes 1, so x times 1 is equal to x, and that's how you get this. So the next rule, which is c to the log of cx, if you remember, I told you exponentials and logs are inverses, so because the c is raised to the power of logs, these two will cancel out, giving you just an x. So keep that in mind, okay? So if you ever have a base of c, and you raise that function to that base like this, like if you had the log of 5 to the power of y equals to 3, and you want to solve for your y, all you do is you raise this function to the power of 5 on both sides. Okay, so what that'll do is this and this has to be the same to cancel it out. And so your y will just be 5 cubed, which will be 125. So keep that in mind, okay? So whatever your c is, if you raise it to that c, they will cancel out and you'll be left with that x. So very crucial rules. We will kind of refer back to them. I don't believe these are given to you on your formula sheet for the diploma, or I don't think the teacher is going to give them to you. These are just something you have to know and learn and practice it enough that they're just imprinted in your brains, okay? No excuses. So the last thing I want to cover for concepts is the actual graph of a log function and how it looks. So remember, an inverse is also the same as a reflection in the line of y equals to x, right? Because that's what an inverse is. Your y becomes your x and your x becomes your y. So this function, if you remember, the blue graph was what we learned in exponential functions, so unit 7. And this again, like the graph says, this is y equals to 2 to the power of x, so this is your exponential function. A logarithmic function looks like this, which is an exact inverse of the exponential function. And then this would be log 2 base 2 of x, okay? So some of the characteristics of a log graph is, if you notice, your x has to be greater than 0 because it's not crossing over into the negative x side, which means there's also an asymptote happening, a vertical asymptote happening at the y-axis or at the x equals to 0 line, because you'll see that this line never crosses over. It just kind of goes closer and closer to the y-axis but never crosses over. So that's why your domain is always going to be x greater than 0. Okay, it's never going to touch 0 because you have a vertical asymptote at the y-axis. The other thing you'll always notice is that your x-intercept is going to be at 1. Okay, and the last thing you will notice is that the range, you're actually okay to be in the positive y and in the negative y, so your y can belong to real numbers. So your range is okay when it's positive and negative, but your x cannot go into the negative side, so it has to be greater than 0. So keep these characteristics in mind. We will get to them again. I think there will be transformations. We'll cover that in the next section. But let's jump into some examples and see how we can apply what we just learned for concepts.